Hello and welcome back. This is video number 3 in a series of videos illustrating getting started example using ABES geometry control software. We will be discussing the definition of cross sections within module geoDes in this particular video. The shape of the cross section and the properties of the cross section we will be inputting in this video is shown on the screen here. The drawing is pulled from the Getting Started manual, which also discusses the same example except in more detail. The cross section mimics the shape of a box section. The outline is shown here. We will define 1, 2, 3 locations for control points along the cross section, and we will define a connection point here at the bottom. This point is used to later on in the process to connect a segment with a pier top at this point. So here we are back in ABES geoDes. We have already started this example and have input an axis in a previous video clip, and just like we did with the axis, we are going to add another object to the object tree here on our left. This time it will be a cross-section object. Right click onto this folder and insert a cross-section, and we will give it a name like we did with the axis object that we already defined, and we will call it box. Simple, for reasons that will become more apparent later. So we have a new object in this folder now, and this is the input dialog that will help us to define the information for this cross-section object. This is the input dialog that will assist us in defining the exact geometry and the properties of our cross-section. It is structured into two main tabs, the General tab and the Domains tab. We will start with the General tab. Imagine a plane that goes perpendicular to the road axis, and imagine a coordinate system whereby the x-axis points into the direction of the road axis and y points lateral and z points upwards. The y and the z coordinates in this coordinate system will be the coordinates for our cross section, and the origin of this coordinate system will be the piercing point of the road axis through this imagined plane. In this table here, which is as of yet empty, we will input a list of the points that form the outline of our cross section. So I don't know how many rows I will need and how many points, so I'll just make a table with 20 rows, and I start with my first point, give it a name 1, and I give it coordinates 9 meters laterally and 0 in the z direction, so we are at the level of the axis here. My second point will go back to 0, 0, and my third point will go to -9 and 0. So these 3 points mark the rightmost point on my cross section on the surface, on the top surface, the center point, and the leftmost point on my top surface. And now I can simply continue with the input of my points, go down maybe 300 millimeters from the last point, and so forth, and create a list of all the points I need to draw the outline or define the outline of my cross section. we have taken a little time lapse here, and I have already filled out the 9 points of the outline of our cross section, plus 3 points here on the top surface, indicating locations of A, B and C, our 3 control points, which we will be using in the casting yard at a later point in time, and point X, which will serve as a connection point. I've put the cross-section has a cross-section depth of 3 meters, and I've put the connection point slightly below the cross-section into the middle of the bearing. That varies from project to project, and that's what I chose to do here. Now, I mentioned that these 3 points A, B and C are control points, and we still need to communicate that to the software. We have these tick boxes here and the CP, which stands for control point, as the header of this column. So if I tick CP for A, B and C, that indicates to the program that these 3 points will serve as control points. And the same for the connection point. XP stands for connection point. I tick the connection point here. Now remember, I initiated the table with 20 lines. Obviously that was a bit too much, and if I accept this data now, I will get an error message because these empty lines, they can't be interpreted. I should clean up the table, eliminate the unused space, and now I can accept and eliminate the error message. With our point locations all defined, we can move on to the last step in our cross-section definitions here. We can switch to the Domains tab, and we can define our cross-section domains. In our case, it will just be one outline, but in other cases we might want to define voids or several parts of the outline. We will keep it simple here, and we will define this table here with the outline of our one and only domain. Same process as we had before. Insert some rows. We know it's only 9 points, and we will use 10 lines to close it. And the way we've named our points, this is a very convenient input. We will start with point 1, move to point 2, 3, 4, 5, 6, 7, 8, 9, and back to 1. And this defines the outline of our simple box cross section. We accept it, and we are finished with the input of that cross section. Of course, we will want to see how it looks, and we do that by right-clicking here on our object which we want to visualize, prepare default diagram, same as we did with the axis, and we get a drawing of our newly defined cross-section. This concludes this third video in this series, and I hope to see you all again in the fourth installment, where we will be talking about the definition of segments.